Okay, now we want to talk about something in geography called a variogram. Okay, so let's look at, we have two data sets, or two geographical pieces of data here, figure 1.3 and figure 1.4. And I think everybody kind of recognizes what we mean by a contour plot. Okay, so we have a contour plot for 1.3 and contour plot for 1.4. And I guess, it tells the heights of the land. Now, I guess we can say we have an x and y axis. So the x-axis goes from 0 to 150, and the y-axis goes from 0 to 100. And then we can talk about a third variable, a z variable, which we don't graph in the standard way, but rather we graph it using color. Okay, so the color is showing the z variable. The z variable is the height. And I'm sure people recognize this kind of map. So, for example, when we see red in the graph, it means that the height is quite large, whereas if we see blue, I guess it's very low. We can think about the set of points in figure 1.3 or in figure 1.4. And every point in the figure has a height associated with it. Now, in one sense, we would have an infinite number of points, but maybe just digitally speaking, we'd have a finite number of points. So we have a finite number of points in figure 1.3, each point having a height, and we have a finite number of points in figure 1.4, each point having a height. Then we can take that collection of heights in figure 1.3, and we can certainly find the average height. We can do the same thing for figure 1.4. We can take the collection of all the heights, and we can figure out the average height for figure 1.4 for data set B. And it's possible that the averages will turn out to be the same. So it's definitely possible. And we can also do the same thing and check the standard deviation of all these heights in figure 1.3 and the standard deviation of all the heights in figure 1.4. And it's possible that the standard deviations will be the same as well. We can check a variety of statistics. We can check so apparently, like here, they've done it, and apparently the number of points is 15,251, and the average height for both A and B is 100, and the standard deviation for both A and B is 20, and the medians are basically the same, and other statistics as well are the same, or close to the same. So, from that standpoint, these two data sets are the same. On the other hand, if we just look at the pictures, we would say that there's something different about them. Obviously, they're not the same, but there's something of interest that's different about them, and that is sort of the continuity of the heights. So in figure 1.4, we have large areas that are kind of high, okay? Whereas in figure 1.3 in dataset A, we may have the same, it's possible we have the same number of tall places, but they're not contiguous, or they're not, it's not kind of a continuous area. It's much more spread out. Okay? But our statistics that we looked at above don't tell us that at all. Okay? So we have an impetus now to develop something that will give us some kind of measure of this continuous nature or lack of continuous nature of the data. So let's read this. What does a variogram represent? Consider two synthetic data sets. So these are just fake data sets. We'll call them A and B. Some common descriptive statistics for these two data sets are given in table 1.1. So we just went through these. The histograms for these two data sets are given in figures 1.1 and 1.2. According to this evidence, the two data sets are almost identical. However, these two data sets are significantly different in ways that are not captured by the common descriptive statistics and histograms. As can be seen by comparing the associated contour plots, dataset A is rougher than dataset B. Dataset A is rougher than dataset B. Note that we cannot say that dataset A is more variable than dataset B because usually more variable means refers to the standard deviation. But we said that the standard deviations were the same. Since the standard deviations for the two data sets are the same, as are the magnitudes of the highs and lows. The visually apparent difference between these two data sets is one of texture and not variability. So how can we come up with a measure of the difference in the texture? In particular, dataset A changes more rapidly in space than does dataset B. The continuous high zones, red patches, and continuous low zones, blue patches, are on average smaller for dataset A than for dataset B. Such differences can have a significant impact on sample design, site characterization, and spatial prediction in general. Okay, so this is the problem that we're trying to solve. Okay, so there's a difference here, and our standard statistical descriptive statistics don't give us a way to get a handle on that, but it's important, and so in various ways, and so we'd like to find some measure of this texture difference. Okay.